In this last presentation, I'm going to talk about, for this course, for Info 365, I'm going to talk about data quality and how that relates to a DBA's and a DBA's role. So ineffective data administration leads to poor data quality, right? It's one of the main reasons we need DBAs. We need people that understand data and how we can ensure the quality of our data. And quality data is really important. We'll talk about a few reasons for that. So there's multiple definitions. If there's multiple definitions or inconsistent representation of the same data or entity elements, this could cause poor data quality. If we're missing key data elements, if we have low data quality levels due to inappropriate sources of data or timing of data transfers, inadequate familiarity with existing data, uh, there could be poor and inconsistent query response times, excessive database downtime. All these different things could you know manifest themselves as poor data quality within an organization. Lack of access because the data is damaged or sabotaged or stolen, right? Or you got some kind of crypto virus or something like that, right? All of this stuff could lead to poor data quality, and it's the job of a DBA to make sure that these things don't happen, so that our organization doesn't have the embarrassment of one of these failures. I'm sure you've all read in the news at some point when some major organization got hit by a crypto virus or something like that, like a local dentist office is, loses all their patient records because of something like that, right? Um, so as far as data and database administration, so data administration is the high level function that's responsible for the overall management of data resources within the organization. And then a database administration is the technical function responsible for physical database design and for dealing with the technical issues such as security, database performance, backup, recovery. And I would say in general, what you're learning how to do in this class. In fact, this next slide to me is one of the most important slides in this class because this is basically what you should be coming away from this class with. Both this class and the follow-on Info 366 at the conclusion of the prerequisite and this class and the follow on to this class, you should be able to analyze and design a database. You should be able to select the appropriate database management software and any other software tools that you need. You should be able to install and upgrade a database management system. You should be able to do performance tuning with your database management system, improve query processing performance by doing things like analyzing indexes and adding hints and things like that, and figuring out how to partition files. A lot of those things that I talked about in the previous unit. Managing data security, privacy, integrity, being able to set up an effective disaster recovery, right? A backup scheme and having a, a recovery point objective that you can meet and so forth, right? So these are all the functions of a DBA, and these are basically what we're learning about in this series of courses. Um, so traditional data administration functions include creating data policies, procedures, and standards, and enforcing those, planning databases, and uh, uh, data governance and so forth, data conflict or ownership resolution, managing the information repository for data definitions, business rules, relationships, right? That's all that documentation that we talked about. Automated data modeling and design tools. We learned about some of these in week 2 and 3. We talked about some of that. Applications that access and manipulate the data, managing those applications and how they access that data. Managing the database management system itself, right? Setting up, configuring, and managing the DBMS, and marketing data administration functions within an organization, right? Why do we need data administration, right? A lot of times we have to justify our own roles within organizations and make sure people understand why it's important. There are some trends right now in database administration. One is the increased use of procedural logic, the proliferation of internet-based applications. This is all the rage now, right? Almost all of our applications are moving to internet-based, which in some ways simplifies things, but in other ways makes things a little bit more difficult with security and so forth. Uh, Everyone's using smart devices now, like mobile devices, like our iPhones and our Android phones and tablets and iPads and stuff like that. So that's definitely a trend, right? Cloud computing is, 5, 6 years ago, it was kind of you know, everybody thought it was kind of a fad, right? Like virtualization, but um, I think we're solidly moving into cloud computing at this point, and that's Definitely a trajectory for databases. There are a lot of database management systems now run from the cloud. You have the ability to use them in the cloud and to deploy them in the cloud. So these are some of the trends that we're seeing in database management systems. Another one is open source database management systems. We're learning about one in this class. We use MariaDB, which is a derivative of MySQL. PostgreSQL is another one. There are some other open source database management systems out there. Some of them hierarchical database management systems, and some of these other data structure based DBMSs. So the advantages to these are you've got a large pool of volunteer developers and testers that we can leverage. They're a lot less expensive than things like Oracle or Microsoft SQL Server. You can view the source code. You can even change the source code to make your own version of these, make your own derivative of these for your own organization. For example, I'm sure that Facebook didn't invent their own database. They probably, you know, took something like MySQL and changed it for their own needs, right? They kind of made it into their own. There are some disadvantages to open source. There may be um, documentation may be difficult to come by, although I have to say that MariaDB and MySQL are extremely well documented. You can find all kinds of really good documentation for MariaDB online. Uh, Licensing can be a little bit of a concern because of the way open source licensing works, but I'd say that most organizations have worked that out, how to deal with licensing with open source. Um, some of the proprietary database management systems do have more features. There's definitely some value propositions behind these proprietary DBMSs. Oracle's got some really cool stuff you can do with Oracle that simply doesn't exist in any open source packages. Microsoft SQL Server is a really strong product. I would say they're pretty close to holding their own against Oracle at this point. Um, and again, a lot of neat things you could do with some things are a lot easier to set up, right? So like Microsoft SQL Server has features like always on, which allow you to very easily create a fault tolerant database cluster, which can be a lot more difficult to do with MariaDB or MySQL or PostgreSQL. So if you're going to be using an open source DBMS, you want to make sure you understand the features that are available, what's not available, what are you missing by using an open source DBMS, how are you going to support it, right? Who are you going to call? If I'm using Microsoft SQL Server, if I have a major issue or a catastrophic failure, I can call Microsoft and say, "Help me," right? They've got experts that can work with me and help me solve those problems. But if I'm using MySQL and I didn't buy it from Oracle, there's no one to call, right? I have to pay somebody for support. Ease of use, sometimes Microsoft SQL Server is super easy. One of the reasons I'm not teaching it in this class is it's a little bit too easy, right? Uh, so MariaDB, is a little bit more challenging. So it's, a little bit more interesting to teach it in a class like this. There could be stability concerns with some of these open source platforms, speed, where you get training. And again, we already talked about some of the licensing concerns. And also, if you embed these open source database engines in your own product or application, sometimes that has ramifications with how you license that product downstream. So, something else to be aware of. So, what exactly is data governance? Data governance is basically the processes for overseeing how data is used and how it's managed, right? So that's basically what data governance is. For example, how long do we keep data? When do we delete data? Uh, what's the quality thresholds for data? All of that stuff falls under data governance. Who has access to data would fall under data governance. Data steward is the person who's responsible for ensuring that whatever our data governance policies are that have been decided by the organization, the steward is responsible for making sure that those policies are enforced and that governance is actually happening, right? That if we have a certain data retention policy, that we are retaining data congruent with that policy, and that could mean that we need to delete data periodically, but it could also mean we want to ensure that we're keeping the right data for the right period of time. All of that stuff is going to be defined through data governance. So for data governments, you have to have sponsorship from senior management and from the business units that use the data. Uh, if you don't have that sort of top-down for data governance, that top-down support, it kind of falls apart, right? You have to have a data steward to support, train, and coordinate these data stewards, you have to have somebody that takes responsibility for that. Data stewards for different business unit subjects and or source systems have to exist. You have to have a governance committee that provides the guidelines and standards that creates that governance that we're going to enforce. So as far as data quality goes, if the data is bad, the business fails. That's really important, right? Quality is very important. I talked about that previously in this course. Uh, there's this old saying, garbage in, garbage out, right? If we put garbage in, we can't expect to get anything better out. Sarbanes-Oxley actually codifies into law that we have to have good quality data. They set standards for metadata quality, right? And we have to comply with those standards. So some purposes of data quality, why we have that, it's going to minimize our risk. It's going to make timely business, or help us make timely business decisions. We have the data when we need it to make decisions that help the organization. Uh, we can ensure regulatory compliance, which is closely related to risk, right? Expand our customer base, right? Because we have all this data, we can, do meaningful things with that data if we have that data. So data is really important, right? And quality data is important. So there's some characteristics of quality data. One is uniqueness. Each entity exists only once within the database. And again, that goes back to normalization. We talked about that. Accuracy, right? It correctly represents the real objects that it's modeling. It has consistency, so the data in one data set agrees with values for related data in other data sets. We have completeness, so we have all of the values that we need. The data is there when we need it. There's no excessive delays when we're trying to access it. Uh, the data is recent enough to be useful. Uh, it conforms with regulatory compliance, and it has referential integrity, which we've talked about before when we do normalization, right? And I know some database engines don't enforce that referential integrity, so that's a decision that we have to make. But certainly you can see how referential integrity, I think, can help ensure the quality of our data. So some causes of deteriorated quality data, there could be external data sources. We don't have control of those external sources, so that could certainly affect our data quality. Redundant data storage and inconsistent metadata could cause data quality issues. And again, we can minimize some of that by normalizing, right? We talked about that before. Poor data capture controls. So poor controls either in our applications or in the database itself. Lack of organizational commitment. So if we don't have that top-down commitment to data governance, right, then a lot of our data quality sort of falls apart. So that's another reason for deterioration of our data quality. The steps for data quality improvement. One, we have to make sure we have business buy-in, that everyone supports and understands why we need good data quality. We have to perform a data quality audit periodically. I'm going to talk more about that here in a few minutes. Establish some kind of data stewardship program. In other words, hold people accountable to data quality. There has to be, some accountability within the organization as to who's responsible for data quality. Improve the data capture processes, uh, which analysts can help us with. Apply modern database management principles and technology, and have some kind of quality management process, or TQM is what our book uses as an example. As far as business buy-in, usually we want to make sure we have executive sponsorship. We build a business case, and we can prove an ROI. It's very easy to prove an ROI on data quality and avoidance of cost. So as far as a data quality audit, if I said this before in this class that you could take whole courses on auditing, on IT auditing, and data quality audits are an important part of IT auditing. It works very closely with database administration, right? So it's important to understand this. We can statistically profile all of our data. We can document values for all fields. We can analyze patterns within our database. We can look for distribution, outliers, and frequencies of data to try to analyze the quality of that data. Your book talks in more detail about specific things we can look for and how to do that data analysis. And there are also tools that you can use to specialized tools rather that you can use to analyze this data. But there's some basic things that you can do as a DBA as well to analyze the quality of your data. So as far as data stewardship goes, usually you have some kind of oversight of a data stewardship program. You manage the data subject area, oversee data definitions, oversee the production of data, oversee the use of data, right? So usually they report to either the IT unit, organization or to the business unit, and that's a decision that the organization would make, right? Is this an IT role or does this? And why would they report to the business unit, not IT? Ultimately, the business unit is who's responsible for their data, right? So sometimes, and again, this depends on different organizations, and sometimes you may even have a chief data officer in some organizations. I don't think that's common, but this would be usually an executive level position that's accountable for all data quality across the organization. And again, that's if you have that, then your executive buy-in is sort of inherent in your data stewardship program. So as far as improving data capture processes, we should automate our data entry as much as possible. Computers make fewer mistakes than humans, obviously. Manual data entry should be selected from preset options where we sort of pigeonhole users into specific options whenever we can. Use trained operators whenever possible. Follow good user interface design principles that prevent, sometimes poor user interface design is one of the major causes of poor data, right? When things are confusing, when it's not clear to the user what type of input they have to put in the system, right? An immediate data validation for entered data to give the user feedback when they put the wrong type of data in, or if it's the data appears inappropriate, for example. And we talked about some of that stuff before. And again, actually, I think depending on what version of this course you're taking, I think I actually use that as a discussion topic, right? Who's responsible for this data quality? Is it the DBA or is it application developers, right? Or with data security, right? Is it the application developers primarily responsible for that, or the DBA? Does it fall in the DBA, or is it a combination of the both, right? Do they share responsibility for that? So there are software tools for analyzing and correcting data quality problems. They can use pattern matching like regular expressions. I could teach a whole class on regular expressions. It's a pretty deep topic, but that's certainly one way to do it. You have fuzzy logic, expert systems, and one thing your book doesn't really talk about is artificial intelligence and machine learning, which is now being used for data management principles, to analyze data quality, for example. We do that at, in my line of work. I work a lot in the medical field, and we're starting to use machine learning to analyze medical records to look at the quality of that data. I talked about TQM earlier. What exactly is a total quality management? Basically, you've got three principles. You want to prevent defects, you want continuous improvement, and use of data of enterprise standards for data. Those are the three pillars of a total quality management policy. And it should be a little bit pragmatic, right? It should be focused on the customer or the user or the product or service, and have a strong foundation of measurement, right? In other words, how do we assess how, the quality of our data? How do we measure to make sure that we are meeting some guidelines or some metrics? And again, we want to be pragmatic about our data quality. We have to, there's always these trade-offs, right? And we have to be cognizant of those. As far as data availability, downtime costs a lot, right? We talked about this a little bit in the previous unit when I talked about security as well. But your book gives us some examples of how much downtime costs. I think this is per hour of downtime, or maybe it's per day. It might be per hour, I think, in these different types of business. The data is kind of old. It's from 2012. I imagine it's much more significant now, right? But here's another example, right? This is also from your textbook, and this is the cost per year. I forget which one of these business sectors this is from, but when we say that I talked about how the cloud has 99.5% uptime. Well, if if my if 99.5 means I'm down for 2,628 minutes per year, right? That means it's going to cost me $4,380,000 per year for that downtime, based on the number of hours, right? So 43.8 hours. I forget which one of these. You can do the math in your head if you're really smart, right? But there's always one in every class that can do this math in their head. But for one of these, I think it's for retail, 90,000, right? But if you multiply it, it's $4 million a year with 99.5%. At 99% uptime, it's costing us almost $9 million a year. But at 5 nines of uptime, we're only looking at $8,000 a year in cost for downtime. So data availability can have significant impact on our costs, right, as a business. And that's how we develop an ROI, right? So if we're developing an ROI to justify these fault tolerant, high availability systems for databases, that previous chart is a great tool to do that, right? You would develop your own based on probably more relevant data. So as far as measuring availability, and again, being able to measure these metrics is important. We can look at hardware failures and provide redundancies for fault tolerance. We can look at loss of data. For example, we can use mirroring to keep secondary copies of our database. In fact, if you use Microsoft Azure, I think when you set up your Azure SQL, it actually tells you that it's going to store your data in 3 replicants. In other words, you have 3 copies. Your database always exists in 3 different distributed geographic regions at any given time, and any of those regions could disappear, and you still have complete access to your data. You have human error. You know, Somebody accidentally deletes records or puts the wrong data in, right? Um, Maintenance downtime. It could be automated. It could be non-destructive, hopefully. Uh, Maintenance utilities, for example, but that could also affect our availability for our data. And then network problems. All of this stuff has to traverse a network. You could have failures in firewalls, routers. Uh, you could have network downtime for all kinds of reasons. Somebody operating the backhoe in the parking lot cuts the fiber, right? So all kinds of things could affect our availability that we have to think about. Uh, and then finally, this is the last slide in this unit. This has been a relatively short unit. I tried to keep the last one short. But master data management is sort of another concept, and this is quickly becoming sort of state of the art in the industry. Your book kind of downplays this a little bit, but MDM is this idea that you have one source of truth for all of your data. So you have some kind of central registry of that's the master of all of the source systems that store data. And if you're looking for information in an organization, you always go to the registry to find out who is the source of truth for that data. And we do this, we're starting to do this a lot in healthcare. I'll give you an example. In healthcare, let's say you've got a large healthcare enterprise that has lots of hospitals. Each hospital might have its own records for patient registration, for example. And you might have a master uh, registry of patient registrations that anytime a patient presents at any one of the hospitals in a hospital system, that system's going to go to some kind of master registry and ask for information about that patient in order to update its files. And there's a name for that. We call it an electronic master patient index or an EMPI. In medical, we have a standard called XDS, which uses repositories and registries, where medical records can exist within repositories, but those repositories register those records in a registry so that if I'm looking for all of the records for a patient, patients might go to many different hospitals, right, within a system. And if I'm a doctor at a hospital, I'm looking up, records about my patient. I'm not going to just look at my own repository. It's going to go out to the registry and say, show me all the places that records exist for this patient, so I can go to those different sources to get that information. So that's kind of what MDM does for us. It's sort of this, you have some sort of hub, which is typically a registry, right? So you have some hub registry, which is registering all of the repositories and what types of information these repositories have. And if I'm looking for information about an object, I ask the registry, where can I go to get information about this? And then it kind of coordinates those transactions across the whole organization. When we look at things like service-oriented architecture and the enterprise service bus, that's where we start talking about things like master data management. So again, it's a really important concept that your book doesn't really talk about too much because it's sort of tangential, I think, to the concepts that are presented in our book. But when you get into the real world, I think it's really important to be aware, uh, of this concept of master data management, that we have these registries that are managing these repositories. And that's it for this course. you've made it to the end of the course. If you have any questions, let me know, and best of luck on the final exam.